Today we are starting our discussion on the next topic in the course, which is about context sensitive languages, the next powerful class of languages in Chomsky hierarchy. And the topic for today is the grammar representation of this class of languages known as context sensitive grammar. Let us recall what we learned about grammars in formal language theory. A grammar G is defined as a quadruple VTSP, where V is the finite set of variables or non-terminals, in our examples represented as capital letters, and capital T is the finite set of terminal symbols. They are known as alphabets for an automaton, but here terminal symbols. One of the variable or non-terminal is designated as the start symbol of the grammar, and capital P is the finite set of productions, also called rewrite rules. And depending on the structure of the production in a grammar can be classified into various classes, and each class represents a class of language in the Chomsky hierarchy. We learned about regular grammars, which are also known as type 3 grammars, and we saw that the family of languages generated by the class of regular grammars is the family of regular languages. And if you recall the structure of productions in a regular grammar, this is the form. We are considering right linear grammar, where the LHS is a variable or non-terminal, RHS is a string of terminals followed by a variable as the last symbol, and this variable may not be present. If present, at most one, and should be the last one in the RHS. This is what is called right linear grammar. We discussed about left linear also, but we are considering here only the right linear grammar. And when we learned about context free languages, we learned about context free grammar. They are also known as type 2 grammar. And the class of languages or the family of languages represented is called context free. If you recall the structure of a production in a context free grammar, it is like a variable in the LHS, and in the RHS any string of variables or terminals. So RHS could be any string, and the LHS is still restricted as a variable. So now you can see that there is no more relaxation that you can give for an RHS, which is already given in a context free grammar. But we saw that certain languages are non-context free, like A and B and C N. So if you want to get a more powerful class of grammar, the only way that you can proceed is you relax the condition on the LHS, and when you do that, you can get more powerful grammars. And the next one in Chomsky hierarchy that we are going to learn in this lecture is about context sensitive grammars, which are also known as type 1 grammars. That is the topic for today. And before we look at an example context sensitive grammar, let us recall some non-context free languages that we discussed. We saw that there are non-context free languages, so we need to have more powerful grammars, and in fact there are infinitely many non-context free languages, not just one or two. We can see some examples. This language is proved to be a non-context free language. We have applied the game induced by the pumping llama for context free languages to prove that this language is not context free. Another example is this language where the set of all strings over the alphabet set ABC, where the number of A's same as number of B's same as number of C's. This can also be proved to be a non-context free language. Proof is not very difficult because L1 is a special kind of L2, because here again this condition is satisfied. Even that subset is not context free. So we can apply pumping llama to prove that L2 is non-context free. So these are example non-context free grammars, sorry, languages. Now the question is there a class of grammar to generate, for example, these two languages? Answer is yes. You can have the class of context sensitive grammars generating these languages, and this grammar is introduced by Noam Chomsky in 1959, and they are useful and more powerful than context free grammars. If we are getting a representation for these languages, definitely they are more powerful. We can see examples. An application other than this, they are useful to describe the syntax of a natural language, where the suitability of a word in a sentence may depend on the context in which that word is going to appear. You know that even if you look at English, depending on the context in which you are going to apply a word, you can see that certain words are more suitable. And to describe such a grammar for a natural language like English, you can go for context sensitive grammars. Now with that motivation, let us try to look at the first example context sensitive grammar. Here a grammar is given with 4 productions. You can easily see that it is not a context free grammar, because if you look at the last 2 productions, the LHS is not just a variable. In both these cases, it is a terminal followed by a variable. So definitely not a context free grammar, but it is a context sensitive grammar. We need to see what kind of a language is represented by this grammar. For that, we can try to look at strings derived, and then we can try to generalize and see what this language is. In the first derivation, as usual, you start from the start simple of the grammar, and if I apply production number 2 on S, I will get small abc, which is a string that we derived. So ABC is a string in the language. Now in the second derivation, you start with the start simple. Now I am applying production number 1, so I am replacing capital S with the RHS of this production. Now suppose I apply the second production for S here, so this S will be replaced with small abc. Now this is not a string in the language, you have to replace this variable with a terminal, and for that suppose I apply production number 3. What is it? Small c capital B can be replaced with capital B small c. You are interchanging. That is what we did. Now you can apply the last production. This small b capital B can be replaced by small bb, and thus we are deriving a square b square c square. Now look at another derivation where we start with the start simple, apply the first production, you will get this. Now try applying the same production again. This is what you are getting. Here this capital S is replaced with RHS of this production. Now to get rid of the capital S, I have to apply production number 2. Do it now. So I am replacing this capital S with small abc. Now if I apply production number 3 for this small cb, I will get capital BC here, capital B small c here. Now I am going to apply the same production again in this place where small cb is replaced with capital BC. And see that we are going for the leftmost derivation. And again now I can apply that production for this cb. This is what I am telling. This small cb, small c capital B can be replaced by capital B small c. Now if you look at this sentential form, this is the production that you can apply for this small b capital B. This small b capital B can be replaced with the RHS, and once more you can apply that here. So small b capital B is going to be replaced with small bb. Now you see that you derived a cube, b cube, c cube. Now we are in a position to generalize that this is the language a raised to n, b raised to n, c raised to n. How will you do that? Suppose starting from the start simple, you apply the first production 0 or more times, say n times. What are you deriving? A raised to n S followed by BC raised to n is what you are deriving. Easy to observe this. Now to get rid of this capital S, there is no other way than using the second production. So you apply production number 2 here. So capital S here will be replaced by small abc. So that A is taken along with this an to get A raised to n plus 1. So this is what you are getting. You expand this BC raised to n. So BC n times. Now what you can do is you can apply the third productions n number of times, which will give you this. Okay, small b followed by capital B n times. And now if you apply the last production n number of times, you will get a to the power n plus 1, b to the power n plus 1, c to the power n plus 1 for all n greater than or equal to 0, and that is the language. Not when n is greater than or equal to 0. Actually, when you substitute as n, it is n greater than 0. So that is the language which is not to be a non-context free language, and now we are getting a context sensitive grammar for that language, and thus giving it a witness that this language or the grammar is more powerful than the class of context free languages. With that simple but illustrative example, now we can formally define context sensitive grammar. You know that only the production structure needs to be defined. So it is a quadruple VTSP where V is the finite set of variables or non-terminals, capital T is the finite set of terminals, capital S is a variable known as the start simple, and these three components are same for all classes of grammars. And what classifies the grammar into type 0, 1, 2, 3 is the structure of the production. And for a context sensitive grammar, the production or rewrite rule can be of the form alpha going to beta, where alpha and beta are any strings of variables and terminals with the length at least 1. See, this is a plus, meaning epsilon is not allowed. Alpha cannot be epsilon, beta cannot be epsilon. See, now the production is more relaxed when compared to the context free grammar. For a context free grammar, the RHS can be even epsilon, and also the LHS is restricted to a variable. And here the LHS and RHS can be any non-empty string of variables and terminals. Not only that, this condition should be satisfied. For any production in a context sensitive grammar, the length of the LHS must be less than or equal to the length of the RHS. The length of an RHS can never be less than the length of the LHS, and hence the grammar is also known as non-contracting grammar. If you derive, you cannot reduce the length of the string that you are deriving. It keeps on increasing or not changing the length. And s going to epsilon is allowed as a special case. Not that in general epsilon is not allowed, but for the start simple it is allowed, provided capital S is not appearing in the RHS of any production, because then this condition will be violated. If S is not appearing in the RHS of a production, then S going to epsilon is allowed. So that is the formal definition of context sensitive grammars. Now it remains us to check why the name is context sensitive. A context sensitive grammar can be converted into a normal form. Normal form means a form to which every context sensitive grammar can be converted. In that, all productions are of the form alpha A beta going to alpha gamma beta. So, whatever be the context sensitive grammar, you can transform them. The productions in the grammar, when I say them, I mean the productions in the grammar, into this form, where what is A? A is a variable, and alpha and beta are strings over variables and terminals, and gamma is a non-empty string over variables and terminals. So alpha, beta and gamma are strings over variables and terminals, where gamma cannot be empty. So that's it. Now you see, what are you actually doing? If you look at the LHS and RHS, when the capital A, the variable, is coming in between two strings alpha and beta, you are replacing only the middle variable capital A with gamma. Alpha and beta remains as unchanged. Thus, you can say that a production of this kind, which is actually replacing capital A with gamma, can be applied only if capital A appears in this context, preceded with alpha and followed by beta. Then you can apply the production A going to gamma, and that is why the name context sensitive, because the variable A can be replaced with gamma provided A appears in the context where A follows alpha and it is followed by beta. If it is coming in that context, you apply gamma for capital A, and thus the name context sensitive. Now going to define the class of context sensitive languages. A language L is said to be context sensitive if there exists a context sensitive grammar generating that language. For example, the language a to the power n, b to the power n, c to the power n, where n is greater than or equal to 1, is a context sensitive language because we have seen a context sensitive grammar generating that language. With this, we are coming to the last part of this lecture, where I am giving you two exercise problems. First one is for you to derive strings and generalize and say what language is represented by the given context sensitive grammar. You can easily see that it is context sensitive, not context free. And recall that context sensitive grammar is more relaxed, and hence every context free language is also a context sensitive language, because every context free grammar is a context sensitive grammar. So, every regular language is a context free language, and every context free language is a context sensitive language because of this. So, that is the first exercise, and this, in the second exercise I am asking you to come up with a context sensitive grammar for this language which is not to be a non-context free language. With this, we are finishing this lecture. Today we looked at context sensitive grammars generating a class of languages, namely context sensitive languages. We saw that we can have a context sensitive grammar for some languages which we proved as non-context free. So, context sensitive grammars are strictly more powerful than context free grammars, and the basic difference here is that we have relaxed the LHS to be any string, non-empty string of variables and terminals. The LHS can be, the LHS and RHS are non-empty strings of variables and terminals, with a condition that for every production the length of the LHS is less than or equal to the length of the RHS, and hence the grammar is also known as non-contracting grammar. And why is it called a context sensitive grammar is, any context sensitive grammar can be transformed into an equivalent grammar in a normal form, where every production is of the form alpha a beta going to alpha gamma beta. That is, actually you are replacing capital A variable with some string gamma only when the variable is appearing in a context where it is preceded by something and followed by something. So, without altering the string before and after that variable, you can replace the middle variable with a string, and hence the name context sensitive grammar. Thank you.